everyone. In this session about monitoring and controlling your microservices with the MicroProfile specification. When you have your architecture with several microservices, you can have a picture like this. Some even have a picture with 100 microservices if you overdo it. But okay, let's maybe have a realistic scenario where you have something like this, 15 or 20 microservices. So how are going we to monitor this? We are sure that if there is a problem in general or just one microservice specific, how do we know it up front without a call from one of our customers saying, oh, that your service is down, it doesn't work anymore. Obviously, we cannot do it manually. We cannot look in the server log or in whatever log for each of those servers or each of those runtimes. So we need to have something automated. We need to have something which is called observability, and then do the things that we need to do and avoid it in the future, maybe. So in this session, I'll tell you a bit more about what is metrics background, a few principles. Probably you all know them already. And then I'll talk about what is MicroProfile, and especially that metrics specification. How can that help us for that picture that I've shown you? And also an important one, and also integrated with metrics, is the fault tolerance specification, because when we are working with a distributed system, we need to prepare for failure. So services can be down, services can be unaccessible, so fault tolerance can help you in that, and it is also linked with metrics so that we have a view of the things which go wrong. And I'll show you also how easy it is to combine those metric informations into a Prometheus database, for instance, and with Grafana alerts and graphics, so that you see that it all can be grouped, linked nicely together. I'm Rudy de Busscher. I'm working for the Payara service team. I'm also a MicroProfile committer, and most of my time I'm also involved with security related things. But this talk is then something different about metrics. That term observability, that means that we want to measure the internal states of our system. A microservice for the point from the end user, it just we send a request and we get something back. But internally there are more things going on. You can have values which indicate how well your service is running. Most of the things that we are interested with, those metrics or the classic ones, are of course things like CPU usage and memory usage. But there is more that can be helpful in this case for the monitoring, and which is called tracing. I give you an example in one of the next slides. And then based on those information and the metrics values and the tracing, for instance, you can define the health of your microservice, and maybe you need to decide that you need to stop one service and restart it, or that the system for you will decide that it needs to be restarted in the hope that it then goes better the next time. So we need to collect data on the behavior of the system, so not the functionality, because that is hopefully done by some testing, but we need to know what's going on within your system and how it is behaving. We need to do it proactively, because it doesn't make sense to start looking at your system when it's already half down, when it's not responding anymore. Then you probably won't find any cause or clues what your issue is. So we need to do it proactively, automatically. And somewhat related is another term which is called application performance management, which also is situated in the same area, but of course metrics and health of your system is more than just performance. It also needs to run and keeps on running. So the metrics itself is just the data that we are collecting. We are collecting values, 24 883, whatever value. We are just collecting them, and we are not going to make any decision for now. We do not know the context of that value, 24, so we cannot say if the value is too high, too low, or whatever. Therefore, we need a baseline. When we have collected a lot of data, we can see if that 24 is a normal value, when everything goes well, or that 24 is an exceptional value and that things will go wrong in the next few minutes or the next few hours. So that's why you need to collect them all the time up front, and you store them centrally so that you can use them in your investigation. When things go wrong, then you can see what is now changed at this moment, which was not the case earlier on the day when everything worked well. I also mentioned tracing, which can be interesting because you have so many different microservices. A lot of people use the distributed tracing option, where you just define a unique ID for each request and you propagate it through all the calls. So you know how the flow of that one single request is through your microservices, which can be interesting for debugging purposes and finding out where a bottleneck is, where is the slowest part of your request. But it can also be interesting in monitoring, because for each request we record, for instance, the time that it's spent at a certain microservice. If you also collect those data, then you can see maybe a trend going on that your slow responses are caused by one specific microservice which goes slower and slower over time. So that is then a thing that you can investigate, and then it's also an important thing, for instance, for monitoring. If you see that it's slowing down, maybe you have logs, you have other issues, and then you can act on that. Once you have collected all the data, you can decide is that value 24, is that timing of your request tracing, is that an acceptable value or not? And you can have a rule in place that say, oh, if it's for a certain period over time, a value which is too high, well, you can just kill that server and restart it in the hope that it then the next time keeps a bit longer, or whatever reason there was for that slow response time. This is different with the situation we had a few years ago, where you had a server, you bought a server, a physical server, you installed your software on it, and so you put a lot of effort in configuring it. So you do not want to just delete everything and start over again, because that was a lot of work. So now with all those containers, that's maybe one of the good things. Everything is automated. You have scripts to start it up easily, so you can just remove your service and replace it by another one. Hence the term which I find a bit denigrating, treat yourselves like cattle, not like pets, because cattle are also animals that you need to respect, of course. So over to MicroProfile and how it can help you in those metrics. Who has heard already about MicroProfile? Okay, a few of them. MicroProfile, in short, is the idea to make your microservices with Java EE applications, or now Jakarta EE, more easily. You still can do it without MicroProfile. You can just use the plain Java EE or Jakarta EE resources and create a microservice with it. A lot of customers are doing that. But you are missing a few things which can be handy in those kind of situations, those architecture areas. Also related to what we are talking today, like metrics. It is if you have something defined which is available for every server, then you can use it in all your situations. Other things like configuration, security, that open tracing, what I mentioned, and Open API, for instance, for seeing the contracts of each service is also part of MicroProfile. So have a look at MicroProfile if you are interested in writing more microservice-like applications, but do not want to give up on your knowledge what you have around Java EE applications. So I start with a simple example, simple demo where we are going to take the metrics from an instance, in this example the Payara server. We are going to take the CPU value, we are going to transfer it to the Prometheus system, which is a time series database, and then with Grafana we create some nice graphic, and we can create, if you need, some alerts with it. Everything will be done by using Docker containers, so it will be portable for whatever system you are using. So I have created a little demo application with a few examples in it. It is a Maven project where I define mainly two dependencies. One is that MicroProfile dependency. I'm still using the 2.0, but the 3.0 is out since a few months, but basically for this little demo it doesn't matter much. I put it provided because the runtimes have that dependency for you already implemented, so you do not need to add it to your WAR file for your application, for instance. And I'm also using the Java EAA API because I'm using some multi-threaded stuff. I will tell you in a minute why I'm using that for my prime calculation. So there is a classic endpoint, so I've defined a path where my service will be callable, and I'm using what's also available within Java EE, which I'm going to use some reactive asynchronous calls. So because that prime value is written on purpose in a very bad way, so that it takes a lot of times, about 7 to 8 seconds to verify a large prime value with all the CPUs that I have available here. So that's why I'm also using that asynchronous stuff here. This is a completely standard WAR file. I do not have defined anything specific for that MicroProfile metrics. They are done automatically out of the box, so you do not need to configure it. You can do it, of course, you can define a lot of things, but it works out of the box. I can start it up here locally, but that's not very sexy today to start something locally, so let's go immediately to that Docker environment. Since I will create 3 different containers within Docker, and they need to communicate with each other, the data needs to flow to the Prometheus database, the Grafana needs to read from it, and it is easier to create a Docker network so that the instances can reach out to each other by their DNS name. So the name that you specify for the container, that is also the name that you can specify in an HTTP connection. So I'm creating a network, and I'm creating a Docker image. So I'm doing a Docker build, which is the standard image for the Payara server, and I'm just copying that WAR file from my application. I copy that to the deployment directory, so that we have an image which has our application together with the server. Next thing is that we can start it. So I give a port mapping so that it is accessible from my local machine here. Here is that name from the Docker container that I'm giving, and that's important later on for the Prometheus configuration. I assign it to that Docker network that I've created, and that's my image name from the container that I have given. So now I have my application running, so I can see if my my prime value calculation is working. So I'm going to use localhost. this is my root context for my application, that's my REST binding, that prime endpoint, and I'm going to use a short value just to see if it works or not. And then I get almost instantly a reply back that this value 939, etc. is a prime value, so he has chosen one and he has verified it. But that verification is written in such a way that it's using all my CPUs. It is using multi-threaded code, but in such a bad way that it's slow and it eats up all my CPU. So next step we can do is the metrics. One of the things that you have with MicroProfile metrics is that you can ask for all the metrics which are available within the system. This format is not very readable because it is created for Prometheus, but it gives all the information that it needs for that system to store this value in that database. For instance, you see here my CPU load is 5% at this moment. So it is doing nothing. So let's put that in the Prometheus database. I'm going to show you this is not what I need. I'm using a Docker file from Adam Bean, which has created one, which is very nice one for Prometheus, and I'm just putting that configuration file into that same image. Important thing here is that Prometheus needs to know where it needs to retrieve that metrics information. So I'm defining here that the target for retrieval is that service. Remember that container name that I gave to my application, so it's service. So that's why it is handy to use here a name and not an IP address, because within Docker it can change quite often. That's that metrics endpoint that I showed you, that page, and I'm just saying every 2 seconds it needs to fetch those data and store it in the database. So again, a Docker build for that image, and I can do a Docker run. Again, important that same network needs to be specified, otherwise the containers cannot talk to each other. This is the Prometheus interface then. We have started up the container, it is available, so I can now have a look at the CPU. I can see that system CPU here. And there you can see that my CPU is around, started about 10%, but is now very low, about 5%. But if I again call that prime calculation, but this time the long version, monitoring prime, it takes some time, around 8-9 seconds. And if you go look then, but you need to request that graph again, then you see that my CPU goes up to 60% because I did not assign all the my available CPUs to that Docker installation, because otherwise Docker can completely shut me out of my own system. So you see immediately that you can easily transfer information. This time it is the CPU, but you have a lot of data available that you can transfer, so that it can easily be connected from one system to another system. But of course, Prometheus is a time series database. It is not created for graphs and alerts like this, so we are going to use Grafana for that. This time we can use the regular image. We do not need to build one, so we can just use the official Grafana container which is available, and we can run that one And now we can play with the Grafana. We need to configure it, of course, because it doesn't know where the Prometheus database is. Initially, we have a username and password, which is not very secure, and I'm not going to change it to another very secure value either, but anyway. So you have that dashboard, you can add a data source, and then you need to tell Grafana where the Prometheus database is. And you need to specify an HTTP like localhost 1990, but it's not on localhost. So let's find out what the IP address is of all our containers. The Prometheus one is this IP address. This is the 0.3. The 0.2 is our service, and Grafana itself is the 0.4. So this is the IP address that I'm interested in, and we can put it here in this place so that it can find it. Now we need explicitly to say, or by name. We can also use here the Prometheus DNS name or the IP address where it can find that information. Save a test successfully, so we can create a dashboard again with our CPU, system CPU, and if I make it here a bit better, only the last 15 minutes, and I do a refresh every 5 seconds, then you will see that it updates automatically, the graphs moves on, and again, if I calculate a large prime value, which I don't know, 20 digit or something, that takes again a few seconds, then you see spiking up that graph again. This is to show you how easy it is to collect information which is exposed by MicroProfile metrics, because it is specifically made in a format which is readable by Prometheus, and once you did the Prometheus, you can use, of course, the standard tools and functionality which are out there in the world.
I have a question. And there is already a set of standard values like the CPU load to show.
Sorry, which standard set of values?
I mean, if I set it up and have this metrics endpoint, do I have already some values?
Yeah. This list here is automatically available for all the implementations. It is defined in the spec that it is required that you have these values exposed at the minimum. But we can expose other values that we are interested in. For instance, maybe we are interested in how many times our endpoint is called. So I have here the typical hello resource, where I have a path hello where I can call a get method on it, and I just put that counted annotation from MicroProfile metrics, and he will just keep a counter going on of how many times I have called that endpoint. So the hello in this case returns where my server is running. And if I go back to the dashboard, I'm always clicking on the wrong one here. Then I can add my counter here. It has a very long name by default, but I just want to show you the default what is available. Of course, you should configure it that it's not the package name, class name, and method name, of course, but you can do it. You can assign it a name yourself, and then you can see that there was 0, there was 1, and now there are already 2 calls. Not sure where that second one came from, but any time you call that endpoint, you will see new entries appear in your Grafana graphic. If you want to update it, and it takes a few seconds, then you see. And it's not coming, but anyway, that is the idea, that you can have custom values of calls, for instance. But the number of calls is maybe interesting for your boss, saying, hey, then you can say every month, oh, our website or our service is that popular or unpopular, because not every site is popular. But you can also have other things which can give you information about if your system is going well or not. For instance, you have also the timed annotation within the same MicroProfile metrics, which keeps time information about the execution of your endpoint. And I have put here a wait time in it, because otherwise it is so fast that you always see that very tiny little value. So I have put here deliberately some wait here. But then you can see the execution time of that specific endpoint. As an example, so I can here put the flaky one, and because it is an endpoint which is flaky in the sense that it sometimes takes more time, I will show it you in a moment. So I have here entries. Now it goes fast because I'm the only user. But if we added a new query, I will show you first here on the page. These are the default one, but the one which are specific for your application, there is a sub page for it. And then you see here, for instance, that timing that we are interested in. And the nice thing here that is it calculates automatically different quantiles. So 50% of my requests are done within 180 milliseconds, and 99.9% was within 300 milliseconds. So I can just take that base name of that metric. So not, of course, I can also take a specific quantile, of course, but I can take the base one, put that in my Grafana. Was there already? No data points, whatever. I'm taking it over. And then you see he adds automatically all those 6 values to one graph. And if I now do something more realistic with a stress testing program, so can have here a little program that can send out requests continuously to that endpoint, and I can start with only one user, so or a low value, so that then you can see that my graph will change, and that we have eventually a nice distribution between our quantiles, and that you have something, because I'm using a random number generator, that it should be normalized standardly, but of course that's not the real world scenario. I'm going to show it for you a few seconds, because my endpoint is written in such a way that when it is used by multiple requests, so that multiple users are requesting it at the same time, that time is slowing down. So that is very realistic in most situations. So now I'm increasing the load to 10, whatever that may be. So that means that there are 10 threads calling that same endpoint, and you see immediately that my timing goes up. So within this, with this at timed annotation, you can find it easy to see how well or how bad your endpoint is doing. Let's stop this. First, properly clean up all the threads and then quit my program. I also mentioned fault tolerance, which is very important, because we need to be prepared for failure. And one of the things that you can do, for instance, you are calling a third-party endpoint, so you have no control over that. The only thing that you can do is call, and you expect an answer, but you know that external endpoint has only an SLA of 90%. So in 10 times of the cases, it will just return an error. okay, it's not a good endpoint that you should use, but anyway, you have no other option than to use it. Since you know that it is only at random that it will fail, and so if you call it the next time, then it will succeed, so you can automatically add that retry by that fault tolerance API specification of MicroProfile. By default, it will retry here now 3 times. So if this fails for some reason, and again, this is determined by chance here with a random number generator, then it will automatically retry. So for the end user, he doesn't see the difference. I have now here a response, but I have no way information about is this now retried or not. Maybe not because I'm doing it only once and it is only 10% of the cases. The second time, is it now retried or not? I don't know. Third time, again, the same thing. So for the end user, everything works well. Maybe sometimes you need to make wait a little bit longer, so that because he needs to retry, but at least he has his values. But internally for you, you like to know, was this, how many times did you retry, did the system retry, so that you can keep your own statistic, because that other party says it's an SLA of 90%, but maybe you want to verify because you have your doubts. Again, you can use some metrics for that, but those are not that easy to find, so I have prepared them here. So you have a few metrics for them, so the retried number total and the total retries and things like that. So you have various metrics which are generated for that at retry annotation. So I can add it. I'm going to create already a few additional, because I need 3 of them. This is the second one. This can also be scripted, because it's now with the demo that I'm doing it by hand, but you can export your dashboards within Grafana and things like that, so you can have all those things done automatically. You can all do all kind of things. You can also determine the number of failures, because when I again put it under stress, then you should see change that value. If you put a low stress, then everything should be okay, and you see the number goes up. It takes longer than when I prepared it before the value shows. But you see already here in the bottom there is already a small 3 times that you need to do a retry, so that was an indication that maybe that's not it's not getting my 90%. And I did it on purpose, so let's put a high stress on it, and then you see that even after 3 retries there were some errors still left. So that can be, of course, an indication that there is something seriously wrong at the other side. And then you can also detect that with the proper metrics in your the dashboard. You see that green one is way too high, regarding that yellow one. So these are the basic things. Of course, you can do a lot with metrics. You have a lot of more things also going on with not this one. You have a lot more going on with that fault tolerance. These slides are online, so I do not have the time to go over them all. But you have more than just retry. You have that classic thing like circuit breaker, bulkhead, and callback, and things like that. So all these things are also linked with that metric specification, so you can have information about how long the circuit breaker was open, and that, for instance, a fallback method was used for your values. But now going one step further, we have now seen Docker, but there is something else that needs to use monitoring, and that's Kubernetes. Kubernetes, probably you all know about it as for the orchestration of your large systems. You can do easily things like deployment. You can deploy more easily a complete set of microservices, but you can easily scale them. If you, for instance, see that one of your services is overloaded, that it's using a lot of CPU, for instance, with that Kubernetes metric server, because you have to install it, but that is available. You can automatically scale your instances from 1 to 2, for instance, so that your load is distributed. But you can also do it for some monitoring. You can take out some values out of that Kubernetes metric server, put it in Prometheus, for instance, and then show it in your graph. So let's try it. It's not always working because I have a lot on my laptop running for the moment. So let's see if it works or not. Let's first kill all that old stuff that we do not need anymore. So I'm going to switch to my Kubernetes tab. Here should Kubernetes be available. Again, I'm going to build a certain image. It's the same app, but it's now built with Payara Micro, because it's not only Payara server, which has all those MicroProfile stuff in it. It's also the Payara Micro, which is created with Kubernetes, for instance, in mind, so that you can make use of that. And then we can apply some deployment to it. So it creates a service. What does that service do? It just takes that image that I have created, and I start 3 replicas from it. So I start 3 times the same application. The only thing that I then need to do is expose that service, which has 3 instances under one name, so that I can access that name, and then that internal load balancer of Kubernetes does its work and balances the request to those 2 instances. So that's with kubectl expose. We expose that, I do it locally, so that's why I'm using here another port, and I will expose that port 8080 from that service, and then I need to have a check to see which port he has taken, because that's most of the time done automatically. So describe service, Payara service. Then you see that this is the port where it is now available, so I can do my curl again, http local host 31.235 monitoring rest. I'm going to take the hello, because then you can see that once here it is served by a certain pod. It's called a pod within Kubernetes with IP address ending on 74. If I do the same call, you see that now it is done by 75. So internally, he does also the metrics, and he is calling the health endpoint from MicroProfile. I have configured it that it is using the health endpoint from MicroProfile to see if my pod, my service, is doing well. So if I have a look at all the kubectl, my pods are here. So these are my 3 pods which are running for the moment. If for some reason one is down, and I can trigger that by sending a kill request to it. So I've created an endpoint which just basically does a system exit. And of course I do not have any reply, but the rest is still working as it should be. But one of the pods should be now in the restarting mode. You see, it has restarted. So it's that kind of monitoring. You can take advantage of it with MicroProfile metrics. For instance, if your service is not behaving as you expect, you can write some kind of test for that. You can expose that through metrics or your health endpoint. It's also defined by MicroProfile. And then you can let know your system, like for instance Kubernetes, that there is something wrong and that it needs to be restarted. I can also expose the CPU data that we have for of each of our instances through that metric service of Kubernetes into Prometheus. Then you need something specific for that. Where is it? Did I close it? Yes, I did close it. So my definition is a little bit different for Prometheus in that case. And now I'm not using a connection to a certain system which is running, like I used in the first example, but now I'm actually connecting with the with the Kubernetes system. So let's see if that works as expected. So again, let's build an image, and that's probably one of the last things that I have time for. So build that Prometheus with that specific config. Again, kubectl apply -f for the service monitoring. That's this starts up now one instance of my Prometheus, which is then connected to that Kubernetes system. I need to expose it. It's probably too long to find it like this. So expose. And if everything went well, I can again go to localhost 9. No, I have to look up the port number. Describe service. Prometheus. It's this port, not 1919. Again, I can look up my CPU, and if everything is well, you see that there are 3 times series now automatically out of the box, because I have 3 instances where that value is exposed, and I have 3 instances where I get called data from through Kubernetes. You can do, of course, a lot of more things. This is just the hello thing that you can do with those kind of things. So the idea is that with MicroProfile you can do a lot of things that are essential in a microservice environment. One of the things is that metrics, which is standardized from your application or your server, you can connect it to Prometheus. You have different types of metrics. You have those system types, things like CPU and memory, but you can also have events. When is a certain endpoint called? Or you can have things from other MicroProfile specifications like default, the tolerance, which I showed you. And also you can integrate it with Kubernetes, which was in the last demo. For MicroProfile, you can have a look at the site of it, microprofile.io. The demo code is available on my GitHub account. I will Twitter those links later on to save to the link to these slides. Time is up, but if you have questions, you can come to me during the break, and enjoy the rest of your conference, and thank you for your attention.